Let's see if we can get this apart without really destroying the gantry. What I want is this section here, because the existing motor mount isn't easy to fit the new stepper. So getting this out would make it far easier. I can measure it up. I can probably create some sort of 3D print that will allow me to drill new holes accurately. Let's see what we can do without wrecking it. Be careful with that one, that has got the lens in, which is absolutely filthy. It looks like the actual runner is bolted separately and there's two big screws holding that in. However, it still is attached obviously to the gantry going across, so I don't think it's going to easily just slide out, but let's see. Let's get this ribbon cable out of the way. Okay, that's interesting how it mounts. There's actually a bit of burning there on the corner. I wonder whether a laser reflection has caught it or it's actually overloaded and burnt. You can actually see burn marks on the side there. Ah, okay, so that's loose now. I think it's actually still attached under there. Just spotted something I didn't spot before. This cover here is removable. That will make it so much easier. Let's do that. That should lift off then. Okay, so if I lift this to there, I'm guessing, yep, right there. Right, here we go. So this is our end. We can see the belt pulleys there. And what we can do is also get this sensor board off, test this Hall effect sensor, which I think I blew, and replace it. So, I mean, the reality is using that Hall effect sensor on this head is great, assuming that we use the original ribbon cable and we get it working again. But it's going to be really simple just to add a micro switch or a Hall effect sensor at the back to do external sensing. So it's not that big a deal. Now I can figure out how I'm going to mount the stepper motor that is almost certainly going to replace this motor in here. It's a very similar size to the other one. It arrived just yesterday. So it's very similar size, but the round one fitted there, as you can see, with a fixing plate, whereas this one's square. So I'm not sure how we're going to get the mounting holes to clear this block there. But we'll figure it out. Here is a picture of the new stepper for the Y-axis and the mount it goes into. You see it fits quite well, but the mounting holes for the bolts are in the wrong place. I 3D modelled and printed this adapter. This fits into the original motor mount and gives 4 holes for the new screw positions. I did exactly the same for the Z motor as well. That also just bolted straight on, so we can drill straight through. What we did here, I took it round to my brother's because he has a drill press or a pillar press, whatever they're called, and the metal was quite soft in this bracket particular. I believe it's aluminium, so these holes drilled really well. The other bracket I think was steel, but even then that drilled quite easily too. The other bracket, I also wanted to increase the hole size. This was because the stepper has got a ring on it that didn't quite fit through the existing hole. So we used a step bit to drill through this. Unfortunately, either my calculations with the original jig or the step bit just cut to the side. Either way, the hole was the right size but was offset, so we drilled a size bigger. I also got a new pulley for the Z-lift. The pulley hole was 5mm, which I thought that the stepper would be 2, but the stepper has got a gearbox on it, which is a 6mm shaft. It wouldn't fit, so we drilled a hole through this too. Unfortunately, somehow this was off center, so it didn't fit. So we took the original pulley, which is 6.4mm, which you can see is loose here, and we shimmed it out with some very thin shim steel, and that seems to have worked really, really well. So that doesn't need, we can use the original cog for that. Here's a photo of the holes where it matches up into the Y motor. That fits really well. This now is the X-axis. This didn't need any extra holes drilling. What it needed was an adapter plate. I 3D printed an adapter plate which I could screw the new motor to, and then the adapter plate screws into the original housing. This seems to work really well. It works the correct offset of the shaft so that the pulley is in the right place for the belt. I will reprint this out of solid PLA Plus rather than a filled PLA Plus to make it stronger. What I'll probably do eventually, if I'm all happy with it and it's working, because I'm a bit concerned that the heat will maybe make the print too soft, which means it might start either pulling out the bolts or moving as it's cutting. So I'll probably send this off to get milled at somewhere like JLC PCB that do really cheap milling. So I'll get it out of a piece of steel or a piece of aluminium when I'm completely happy with the design. So the next step will be to do an electrical test with all of the motors, probably on the bench rather than in the machine, to make sure they all work. And then after that, we can actually fit the motors and fit the controller, which, although is a relatively easy job, I want to take my time and make sure it's all done correctly and all the cables runs are done correctly, so that we don't get, so it's all neat and, it's going to try and last for a long time. I want it to look professional.